Today we will discuss the data models. Now, after studying a very important topic, that is the DBMS architecture, we should dwell upon a topic that is known as the data models. Now, how is basically a database represented, or how do we define the underlying structure of a database? So this is with the help of data models. A data model basically describes the overall structure of the database. That is, it describes the data, what the data will be, and what the relationship among those data would be. So you can, in a way, you can think of the data models as a blueprint. That is, before the database is actually comes into existence, or before the database is actually made, what we do is we make a blueprint kind of a thing, that with the help of our data models, so that we can know what is the underlying structure of that particular database, what all the data, what all the datas are there that would be described in the database, what would be their data structures, what would be the relationship among those data. So in a layman's language, it is nothing but a blueprint of the database. That is, before a database is actually designed, we define what the data in the database would be and what would be the relationship among those data in the database. So this is a data model. So we can say that the definition of data models is that they use they describe the data and the relationship among those data through conceptual tools. So basically we have two different categories of the data models. The first one being object based models and the second one being the record based models. Two different categories, that is, the model data models are divided into two major categories. The first one is the object based models and the second one is the record based models. Now first we will start with the first category, that is the object based models. The object based model further contains two different types of models: the entity relationship model or the ER model and the object oriented model. Now first we will start with the entity relationship model or the ER model. The ER model is the most important and the most widely used model in a database management system. So since this is a very important model, so it itself is a topic so this is a topic in itself, and hence we will discuss this particular model in a lot more detail than other models. Hence we will discuss this model at the end. That means after discussing all other models, at the end we will discuss the ER model in detail. As of now, ER model basically represents the data with the help of entities and the relationship among those entities. Just to give you a brief introduction of what an ER model is, ER model is nothing but a collection of entities and the relationship among those entities which are representing the data and the relationship among those data in the database. Entity, as I told you in the previous videos also, is nothing but a real world object regarding which you want to store the data inside the database. For example, I told you student is an entity, a faculty is an entity, a customer in a banking database is an entity, the account in a banking database is an entity. So basically any real world object regarding which you want to store the information or data is an entity. So basically the ER model revolves around the entities and relationships among those entities. This particular model we will discuss in detail after we finish with these models. So to the next model in the object based models is the object oriented model. Now this object oriented model basically describes the data as objects. That is, the records are represented as objects. and an object encapsulates the various data variables and the methods and functions that will manipulate those data and variable. This is an object B, for example, right? So an object will, what will an object consist of? Basically the records. Database caters the records. So what is a record referred to as in an object oriented model? A record is nothing but an object. So the object based model represents the records as objects. What does an object encapsulate? An object encapsulates the data, which are also known as variables, and the methods, which are also known as functions, to manipulate this data or to manipulate these variables. The objects of similar type and methods or functions of similar type can be grouped together in a class. That means a class will contain various objects of similar type and various functions and methods of similar type to access those objects. I'll repeat it once again, that an object is nothing but a representation of the records of the database. These objects contain, what do these objects contain? They encapsulate the data, the actual data, which is also known as variable, and the methods or functions which will be used to manipulate these data or variable. Now, the collection of objects of similar type and the collection of methods of similar type is grouped together into one class, and like this we can have several classes. Now we have another object A. This object B is representing a records of one particular type, and this particular object is representing records of another type. Now this object A wants to access the data of this object B. How will it do that? The object A will access the data of object B by invoking the methods of object B, right? At any point of time, if object A wants to have data regarding object B, it will invoke the methods of object B through an interface. For any two layers, any two layers to communicate with each other, there needs to be an interface. So basically object A will communicate through object B with object B through an interface. What is this interface providing? This interface is providing object a mechanism to invoke the methods of object B. Why is object A invoking the methods of object B? Because it wants to have the access to the data of object B. So basically these methods or functions are made available to the external world so that any other object, if wants to access the data of that particular object, can invoke those methods or functions. So this is the concept of object-oriented models. So basically when we talk of object-based models, we have two different types of models, the ER model and the object-oriented model. Next, we move on to another category of data models, that is the record-based models. In the record-based models, further we have three different types of models: the hierarchical model, the network model, and the relational model. So, we will start with the hierarchical model. We are talking of the record-based model. Within the record-based model, we have three different types of models: hierarchical model, network model, and relational model. We will start with the hierarchical model. Now, hierarchical model follows a hierarchy. As the name suggests, it follows a hierarchy, a tree structure. So, wherein we will have one parent node and we can have one or more children nodes. This is a tree hierarchy. So one parent node and one or more than one child node. So here we have the records, or the data is represented as records over here. What are the three different records over here? These records are the course, the teacher, and the student. Right now I am talking of a college database. So the three different records in a college database would be the course, the teacher, and the student. Now in the hierarchical model, the course is the parent node and the teacher, the course record is the parent node, and the teacher and the student records are the children node. Now since the limitation of the hierarchical model is that at any point of time a child node can have at most one parent node, not more than one. I said at most, that means it can have only one parent node and not more than one parent node. So the relationship here is one to many. One node has relationship with many other nodes, or one record has relationship with many other records, and these many records have relationship with one record or one node. So it does not support many to many relationship, it supports one to many relationship. Now here course record, teacher record, student record, right? Course is offered by teacher. The relationship among different records here are represented through the links, which can also be viewed as pointers. These links represent the relationship among different records. Now course is being offered by teacher. This is the relationship between the course and teacher record. Again, course is being attended by students. This is again the relationship between course and student record. But what is the relationship between the teacher and the student? Here I am not able to find an association between the teacher and the student. Yes, and the teacher and the student, of course, being two different records in the same DBMS, cannot exist without an association between the two of them. So what is the relationship between the teacher? Obviously the teacher must be teaching some students, or the students must be studying by some teachers, but here I am not able to represent that association because the limitation is that one node can have at most one parent node. Now if I make an association between teacher and student like this over here, then this student record will have more than one parent record. That is, one parent record is this and the other parent record is this. Yes, similarly the teacher record will have also more than one parent record. One parent record is the course and the other parent record will be the student, which is not possible in case of a hierarchical model, since it strictly imposes the restriction that at any point of time a node will have only one parent node. So because of this this restriction, I am not able to give the association between a teacher and student. Further, I can only make out what courses are being taught. I am only being able to make out that this course is being taught by how many teachers. But if I want to find out which teacher is taking what all courses, for this again I'll have to have a pointer from the teacher to the course, which again becomes one many to many association, which is not being offered by this model. Because if I have a link from teacher to course, that means teacher will have more than one parent record, which is not possible. Again, the association course attended by students. This course is attended by these all students, I am able to know, but I am not able to know which student is attending which all courses, because again I cannot have more than one parent record. So these are the limitations of the hierarchical model. Because of the restriction that one record or one node can have at most one parent record, many associations are not being able to represent in this particular model. So next is the network model. The network model basically improvises the hierarchical model. Here the data is again represented as records, that is as a arbitrary graph. How? As records in the form of arbitrary graphs wherein each node can have more than one parent node. You can see the difference. In the hierarchical model we were following a tree structure, so any record at any point of time could not have more than one parent node or one parent record in the. So because of this we were facing the problem that there were so many associations that we were not able to represent through this particular model. There was existing an association between teacher and student which we were not able to represent because of the limitation that each node can have at most only one parent record. So it has, this network model has overcome this limitation by following an arbitrary graph structure. That is, the nodes, that is the data will be represented as records but as an arbitrary graph, and the relationship among those nodes or those records will be represented as these links, or we can also call them, view them as pointers. Now here the limitation which was we were facing in the hierarchical model is being overcome here. Course is a record, teacher is a record, student is a record. Course offered by which all teachers we are being able to find out through this association, offered by. Course attended by which all students we are able to find out by this particular association, course attended by students. Now here what we were not able to find out was that which the teacher, one particular teacher is offering which all courses. Here we are able to find out that association, teacher offers courses. Again, one more association which we were not able to find out here is that student is attending which all courses. Now here we are able to find that association, student attends course, because there is no limitation that at any point a record will have only one parent node. A record can have more than one parent records or more than one parent nodes. So the associations which we were not able to represent in the hierarchical model, we are being able to represent in the network model. What were those associations? That which, that a teacher teaches which all students, that a student is taught by which all teachers, that a teacher is offering which courses, and that which all courses are being attended by a particular student. These associations are now being able to, we are now able to represent these associations in the network model, which earlier we were not able to represent in the hierarchical model. Therefore we can say that a network model supports many to many relationships. Many nodes can have relationships. The one node can have more than one parent node, hence many to many relationships is being supported by the network model. The last model of the record based model is the relational model. Now this relational model basically represents the data inside the database as a collection of tables. That means each record is represented as a table. For example, the student record here. If we want to represent a student record, we will represent that student record through a table. This table is known as a relation. In terms of the DBMS, in a relational model, when we make a table to store the records of a particular, when we make a table to store the records, that particular table is known as a relation. Now this relation can have as many rows. These are the rows which are going horizontally. These we call the rows. They can be as many rows. There is no limitation on the number of rows that a relation can have. Each row of this relation is known as the instance of that particular relation. This row is an instance of the student relation. This row is again an instance of the student relation. So each row of the relation or the table is known as the instance of this particular relation. And the columns of this relation represent the attributes of the particular relation. For example, the student relation, the attributes of the student relation are the roll number of the student, the name of the student, the course in which the student has enrolled. These are all the attributes of the student which are represented as columns, and there may be several such students whose record we want to store in the student relation. For example, one student is having roll number 1, one student is having roll number 3, 2 and 3. One's name is A, one's other's name is B, and the next one's name is C. So different students having different attributes are stored in one particular student table. So because they have similar kind of records. So each instance, that is roll number 1 is an instance of the student table. Roll number 2 is an instance of the student table. Roll number 3, student name C, is also one instance of the student table. That is, each row represents an instance of that relation and each column represents the attributes of that particular student relation. Similarly, we may create several other relations. Like for faculty, we may have a separate relation. For say in a banking database, if we take example, we may have a customer relation to store the details of a customer. We may have an account relation to store the details of the accounts. So this is how the records are represented in a relational model, and the associations among each relation, the relation is representing records. So basically the association among the records or the association among the relations is represented using foreign key and primary keys, which we will discuss when we discuss the entity relationship model. So I hope the data models, the concept of data models is clear. The object-based models, record-based models, entity relationship model, object-oriented model, hierarchical model, the network model and relational model are now clear.